as we're moving forward with our limits, we've got to look at a couple more things, okay? So here, what we're looking at is limits involving infinity. Okay? There's a couple different things we're going to do here, so we're going to see a couple different videos. But this one, what we're noticing here, just from our picture, is we're looking at vertical asymptotes, right? We can tell if a function has a vertical asymptote by the behavior around an x value. So that's kind of what we're going to look at here. Okay? We can see it visually from our graph. Let's start here at x equals 3. All right? So if I were to say the limit as x approaches 3 from the right, we're going to go ahead and call this function f of x. So as I get closer and closer to 3 from the right, well, it's just going to infinity, right? It's getting closer and closer to that asymptote. It's just going to infinity. Cool. Same thing is true if I were to say the limit as x approaches 3 from the left. So as I get closer and closer to 3 from the left, I'm still approaching infinity. So the left side and the right side limits exist. So I would say the limit as x approaches 3 is infinity. Both of those pieces right there are going to infinity. Whee! Okay. But if we take a look at -2, so my asymptote here, I have one going to infinity and one going to negative infinity. So the limit as x approaches -2 from the left is going to infinity. But the limit as x approaches -2 from the right is negative infinity. These values don't match, so the limit as x approaches -2 does not exist. Okay, because they're going to separate places. Both of these are examples of seeing what a vertical asymptote looks like based on its limit behavior. Okay, just as an example, when we see this is not my function, so I'm not going to call it f of x. We're going to go ahead and call this guy g of x. And if we had 1 over x plus 1. Okay, based off of our previous math knowledge, we know that when the denominator equals 0, that's where we see a vertical asymptote. So here, we're going to see a vertical asymptote when x equals -1. Okay, so I want to know what or how that graph is behaving around -1. So what I could do is I could say or build a table. So I'm going to look at the limit as x approaches -1 from the right. So as I'm getting closer and closer to -1. So -0.999, -0.99, and -0.9. As I plug these values into my function, we're going to see what's behaving at that point. Whee! Okay. So just really quick, if I have 1 divided by -0.9 plus 1, this gives me 10. Okay? 1 divided by -0.99 plus 1, that gives me 100. 1 divided by -0.999 plus 1, that gives me 1,000. So as we look, as I get closer and closer to -1, this is just going to keep getting closer and closer to a positive infinity. So we can evaluate our limits, left side and right side limits, using a table to determine if we're going to infinity or negative infinity. Vertical asymptotes, we're going to see our limits approaching infinity. Good luck.